So, hello friends, I welcome you all on this YouTube channel. You are most welcome. So, on the demand of the students, we are going to make a video on the thermal power plants, right? How does a thermal power plant operates? What are the various components which are connected inside the thermal power plants that we are going to discuss now, right? So, just have a close look at it. This is a schematic diagram of a thermal power plant. This is a schematic diagram of a typical thermal power plant, right? So, these are the various components which are connected, right? So, this is the, you see that first of all you should understand that major electricity production in India is achieved through thermal power plants. That means from the coal based power plants, right? So, that means around 70%, around 70% of the electrical energy production is from the thermal power plants, around 70%, right? So, these are the various components that are connected here as you are watching on the board, right? So, just have a close look at it. This is the coal storage, right? This is the coal handling plant, right? So, 50% of the area is being occupied by the coal handling plant itself. So, capital B is here representing the boiler, right? Capital B here representing the boiler. Capital B here is representing the boiler, right? And this is the superheater, right? As you are watching here. This capital T represents the turbine, right? Turbine basically it is coupled with the alternator, right? And here you see this capital E, it is representing the exciter. So, DC excitation is given to this rotor of this alternator, right? So, and here you see that this is the condenser, right? And this is the cooling tower. So, what is the use of condenser? What is the use of cooling tower? So, that we will discuss later, right? Here you see this is the water treatment plant, and here you see this is the river. So, this is the river. So, it is advisable that we should construct our thermal power plant at a site which is nearby the river, right? So, that adequate and sufficient amount of water can be achieved from the river. So, it is always advisable that you should construct a thermal power plant at a site which is nearby the river, right? So, now see here, look at here, this is the step up transformer, right? So, once the power is generated, right? So, turbine basically provides the mechanical energy to this alternator, and now alternator basically it will now convert this mechanical energy into electrical energy, and this electrical energy is now ready for the transmission. And we should always remember that this electrical energy that is transmitted always and always at higher and higher voltages, right? So, these transmission voltages are higher. Why? Because we want to reduce the transmission losses primarily, right? So, that is why the transmission losses are higher. So, standard power generation voltage is 11 kilovolt, that is standard power generation voltage, AC power generation voltage in India, right? But when we talk about the power transmission, then definitely it would be done at higher and higher voltages, right? So, the power transmission voltage, it can be 220 kilovolts, it can be 400 kilovolts, it can be 765 kilovolts, right? So, these are some of the standard power AC power transmission voltages in our country India, right? So, this is since we need to transfer this power at higher and higher voltages to reduce the transmission losses. So, nearby this generator we need a transformer, we need a step up transformer which will basically step up the voltage level, right, of this power that has been generated by the alternator. So, this is a step up transformer, right, to step up the voltage, right, up to 220 kV or 400 kV or 765 kV or whatever the voltage transmission voltage is there, right. CB here represents the circuit breaker, this is the isolator. CB means circuit breaker, it breaks the circuit in the loaded condition. Isolator, it will isolate the circuit at the no load condition. R by B here represent the transmission lines, right. So this is the water treatment plant, right. Now here we shall discuss one by one. See here, this is the coal storage, right. This is the coal storage. So you see that the 80% of the coal, right, 80% of the coal, 80% of the coal of the India comes from the Coal India Limited, CIL, right, Coal India Limited. 80% of the coal of India comes from the Coal India Limited. It is a Maharatna company, and currently Coal India Limited is operating 345 mines in 345 mines, right, at various locations, right, in our country. So I'm not going the details, datas, statics and number crunching and all that you can Google at any time, right. So so here this is the storage of the coal, right. So storage of the coal is necessary, right. Storage of the coal is necessary. Why? Because you may have shortage of the coal. As per the current scenario, you are observing that there is a shortage of the coal, right. So storage of the coal is necessary, right, for protection against coal shortages, right. Storage of the coal is necessary in case of failure of transportation of the coal. Storage of the coal is also essential, is also necessary in case of coal strikes and all. So in all such cases, that means the storage of the coal is necessary against the coal shortages, against the failure of the transportation, against the coal strikes and all. So due to all these problems, we first ensure that there must be adequate storage of the coal, right, in advance, right. So from coal storage, coal will go to the coal handling plant, right. Coal will be delivered to the coal handling plant where it is pulverized. Coal is pulverized at coal handling plant. And when I say pulverized, what is the meaning? Meaning is that the coal is crushed into small pieces, right. Why do we crush? Why do we pulverize the coal? Why do we crush the coal into small pieces at the coal handling plant? Why? Because the reason is because we want to promote the rapid combustion of the coal, right. So in order to promote the rapid combustion and proper combustion of the coal, and in order to increase the combustion efficiency of the coal, pulverization of the coal is necessary, right. That means we should crush the coal into small pieces. So due to pulverization, basically what happens, the surface area of the coal, it increases, and coal is now ready for proper and rapid combustion. So that's how the combustion efficiency of the coal increases. Now the coal is fed to the boiler furnace, right. So now this will go to the boiler furnace, and coal is burned into the boiler furnace, right, and ash is now produced. So this ash now, it is now delivered to the ash handling plants, right. It is now delivered to the ash handling plants, and from ash handling plant, the ash is now being delivered to this ash storage. So now ash is also useful, isn't it? Because ash can be used in the cement making industry, ash can be used in the brick making industry. So ash can also be utilized. So suppose this thermal power plant is of 100 megawatt capacity, and if it is operating at 50% load factor, isn't it? So suppose if it is a 100 megawatt capacity thermal power plant, and if it is operating at 50% load factor, then it may burn around 20,000 tons of coal per month. Yes, 20,000 tons of coals per month, isn't it? And 10% of that, that means around 2,000 tons will be the production of the ash, that will be given to ash handling plant, and that will be eventually given to the ash storage, that will be given to the cement industry, brick making industry, and for all other industrial utilization of the ash, right. Now the coal is burnt into the boiler, right? So this heat energy of coal combustion in the boiler is used to convert water into steam, right? So this heat energy of coal combustion in the boiler is used to convert water into the steam, right? So you will have flue gases coming out of the boiler, right? They will now go to the superheater, right? So these flue gases, right? This steam which is coming out of the boiler, it is not directly allowed to pass on to this turbine. Why? Because the steam which is coming out of the boiler now, it is containing moisture, it is wet steam, right? And if you directly allow this wet steam containing moisture, if you directly allow this wet steam onto the turbine blades without passing it to the superheater, then what will happen? Then this wet steam, this steam which is having moisture content, it will corrode the turbine blades, right? It will corrode the turbine blade definitely, for sure, right? That means, first of all, it is very much necessary to pass on to this steam into the superheater. So superheater, basically what it will do, it will basically superheat the steam, right? It will superheat the steam, it will increase the temperature and the pressure of the steam. So now the steam becomes completely dry, right? Now the steam is dry completely, and now it is superheated, and now it is ready to pass on to the turbine blades. So now you can imagine the temperature and the pressure of the superheated steam. It is very, very high, right? So now you will pass this superheated and dry steam onto this turbine blades. So turbine blade starts rotation. So that's how the steam energy gets converted into this into mechanical energy in form of rotation, because the turbine blades are now rotating, right? So now steam energy gets converted into mechanical energy by the turbine action, right? Turbine blades are rotating, that means steam energy gets converted into mechanical energy, right? And now this turbine is coupled to the alternator, right? Turbine is coupled to the alternator, turbine is connected to the alternator, turbine is connected to the alternator. That means now mechanical energy gets converted into electrical energy by this alternator, right? So alternator is basically synchronous generator. How it converts, how does it convert mechanical energy to electrical energy? I have made a separate video on that. Please visit the same YouTube channel for that. Operating principle of synchronous generator, that is basically alternator. There I have completely discussed this process of mechanical to electrical energy conversion, right? So once the electrical energy is generated at 11 kilovolts, that is a standard AC power generation voltage in our country, right? Then we need to transmit this power at higher and higher voltages, right? So that means we need to step up this voltage up to a high value, right? From 11 kV to 220 kV, let us say 220 kV, or let us say 400 kV, or let us say 765 kV, or like that. These are the standards, some of these standard transmission voltages. So we transmit the power at higher and higher voltages because we want to reduce the transmission losses primarily, right? Now what is the role of condenser? What is the role of condenser? Why do we use condenser and why do we use cooling tower? What is the role? What is the function of this condenser? See, the condenser that you are watching here, this basically the steam that is coming out of this turbine, the remaining steam which is coming out of the turbine, right, that is if you directly release this steam into the atmosphere, then it will be completely wastage of the steam, right? So we will not waste this steam into the atmosphere by directly releasing the remaining steam coming out of the turbine. We will not directly release into the atmosphere for wastage, right? Rather, what we will do, we will pass on this remaining steam coming out of the turbine into the condenser, right? So condenser basically involves into the condensation process. And when I say condensation, what is the meaning? Condensation means cooling. Condensation basically means cooling. So cooling means the steam gets converted into the water, right? The steam get converted into the liquid again. So vapor and steam gets converted into the liquid again, right? So here you see these are the cooling tower, right, for cooling purposes. So cooling tower are basically long height structures, right? We are basically sprinkling the water from the top to the bottom ground, right? Air is basically blowing in below the structures, right, of the cooling towers, right? Around the atmosphere air is blowing. So that's how the cooling of the water will take place, right? Now suppose if there is some steam that is still remain that is still remaining that is still not converted into water, then again we will feed this unconverted steam into the condenser. Then condenser will again condense this steam, that means again it will cool the steam, again it will feed to the cooling tower, again this cooling tower will be subjected to atmospheric air and all, again we will sprinkling the water from the top to the bottom ground, then again it will be converting into the again it will be cooling down, and again this process will repeat until and unless all the steam gets converted into the water, until and unless all the steam gets converted into the cold water, right? So now this is it is a feedback process, right? So that's how we are basically avoiding the wastage of the steam, right, which is coming out of the turbine, right? So there is one steam which is being utilized for the electrical energy production, right? But the remaining steam that we are getting out of the turbine, that we will not allow to pass on to atmosphere directly, right, for wastage, right? So rather what we will pass this remaining steam coming from turbine to the condenser, and condenser will condenses this steam, it will cool down, and it will convert this steam into the water using cooling tower, and that's how this process it will keep on going like that. And now we can utilize this water into further purposes. This feed water, this is called feed water, right? So this feed water is now given to the economizer. Economizer, what it will do? Economizer, it will heat the flue gases, it will heat the feed water. Economizer, it will heat up this feed water, it will preheat this feed water, right? So it will increase the temperature of this water, right? So suppose this economizer is now increasing the temperature of this water, right, using the heat energy of the flue gases, it will increasing the feed water temperature, and suppose it has increased the temperature of the feed water by 30%. Then now before feeding it to the boiler, you will have to further increase the temperature up to 70 degrees Celsius, right? That's how it will work. So economizer, what it will do, it is basically a feed water heater. It is a feed water heater. It will basically improve the efficiency, or overall efficiency it will improve, right? So it's a feed water heater. It will heats up the feed water using the heat energy of the flue gases. So now from here, this you see this is the air preheater. What is the job of air preheater? Air preheater is basically air preheater increases the temperature of the air supplied for the burning coal, right? Supplied for the burning coal, right? By using the heat energy of the flue gases. So air from this atmosphere comes into the forced draught fan, and then it will go to the air preheater, and then it is feeded to the boiler. It is feeded to the boiler furnace, right, for rapid combustion, right? So that's how you will see the steam power plant will work. And this is the remaining gases. We will use electrostatic precipitator. So the harmful emissions, that means oxides of nitrogen and sulfur and particulate matter, they will be extracted by the electrostatic precipitator, and the remaining it will be left out into the atmosphere as an emission through the chimney, right? So water treatment plant that you're watching here, this is basically we will first demineralize the water, right, before converting into the steam, right? So for that we have water treatment plant, or you can